Okay, this is Chapter 6, Section 2, and we're going to talk about subtraction of signed numbers. So the, the objective that we're trying to accomplish is being able to subtract signed numbers. When the number line is extended to the left to include the negative numbers, every positive number can be paired with a negative number whose absolute value or distance from zero is the same. These pairs of numbers are called opposites. For example, -3 is the opposite of +3. +5 is the opposite of -5, and so on. 0 has no opposite because it is neither positive nor negative. We know from basic arithmetic that 5 take away 2, or 5 minus 2, is equal to 3. From the rules for adding of signed numbers, we know that 5 plus -2 is 3. Also, therefore, +5 minus +2 or equals +5 plus a -2, which is also 3. This means that subtracting +2 is the same as adding its opposite. Subtracting and adding the opposite are equivalent. What happens if we subtract a negative? For example, how can we solve the problem -5 minus a -1? Well, if we rewrite the subtraction as an addition of the opposite, we would have 5 minus a -1, or 5 take away the opposite, right? The opposite of -1, and the opposite of -1 would be a +1. So if you think about this as saying that this is the opposite of -1, the opposite of -1 turns into a +1, and that would be 6. We can now state a rule for subtraction of signed numbers. To subtract two signed numbers, follow this two-step rule. Rewrite the subtraction as an addition of the opposite and use the rules for addition of signed numbers to add. So, for example, if we have 3 take away 7, we would have +3 take away a +7, which would be 3 plus a -7, which is -4. And if we talk about, if you remember the number line, okay, if we are at 0, 1, 2, 3, and it's asking us to add -7, well, we're moving in the opposite direction. So we would move to the left 7 spaces, 1, 2, 3, and then, so we've moved 3 spaces. We would need to go back, and that would take us all the way back to 4, 5, 6, 7, -4. -2 minus a -6, which remember that the negative sign, when you see negative, you're saying the opposite of a -6, which is really +6. So if you're looking at a number line and you're starting at -2, okay, if we're starting at -2 and we're adding 6, then we would move to the right 6 spaces, come up with +4. Okay, so this would be -8, and remember that we read this as the opposite of -3, which is +3. So when you start on your number line at -8 and you add 3, you're going to need to move 3 spaces to -7, -6, -5 to the right. We're adding a positive number. Okay, so if we have -4 minus 9, you could rewrite this as -4 minus a +9, or you could say -4 plus -9. So, I mean, think about this one. We're already at -4 on our number line. Okay, and we're going to have to go back 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Well, this is So -5, -6, -7, -8, -9, -10, -11, -12, and then we would finally be at -13 if we went and we subtracted 9 and went to the left. Never change the sign of the first number. You change the sign of the second number only when changing subtraction to addition. So they've kind of got their example with the chips here again. So let's look at one of these problems with the chips. You can kind of see. Let's go back up here and look at -8 minus -3. Now what you do need to know is, so if you did -8 minus -3, you still need to go, oh, that's the opposite of -3. So this really means -8 plus 3. And I don't know if you remember this from the section 1, but the negative numbers gave us blue chips. So 1, 2, 3, 4, 5, 6, 7, 8. And the positive numbers were clear or white chips. And so one of these cancels out one of those. A non-filled in one would cancel out one of the blue ones, and we would be left with 5 of the blue chips, which would be negative. And so that's just a visualization of how you could see that. Customers who install solar power systems can usually sell their excess electricity back to the utility company. This is called net energy metering, and it may result in a negative monthly bill if the compensation for excess electricity exceeds any monthly fees to operate and upgrade the grid. Suppose a utility charges solar power customers a fixed monthly fee of $20, but it compensates the customer 6 cents per kilowatt hour exported to the grid. To determine the customer's net monthly bill, we multiply the number of kilowatt hours exported to the grid by 6 cents and subtract this from 20. So for a customer who exports 280 kilowatt hours to the grid in a particular month, well, we would take the charge of $20 minus 280 times 6 cents, which gives us a positive $3.20. For a customer who exports 392 kilowatts, it would be 20 minus 392 times 6 cents, which is $3.52. The negative result indicates that the utility owes the customer $3.52 for the month. And that is the end of Chapter 6, Section 2.